My name is Jean-Tori Pantel, and I would like to present to you the second stage of the PEDIA study. PEDIA is an abbreviation of Prioritization of Exome Data by Image Analysis. When a geneticist sees a patient, he compares the face of the patient in his mind to all the cases that he has seen so far, and he comes up with a list of differential diagnoses. This is exactly the process that computer-assisted pattern recognition is imitating, just in a more quantifiable way. As an example, I would like to visualize here the comparison of the patient with two syndromes. First, hyperphosphatasia with mental retardation syndrome, short HPMRS, and second, Cornelia de Lange syndrome. The heat map shows areas with a high degree of concordance with a representative syndrome mask. Overall, the similarity to HPMRS is higher. That's why this syndrome achieves a better Gestalt score. However, a diagnosis can rarely be based on the visual impact alone, and usually requires molecular confirmation. Both depicted syndromes here are heterogeneous disorders, and the method of choice has become an exome analysis. There are about 20,000 variants per individual in the coding part of the genome. Most of them are common polymorphisms that are shared with the general population. However, about 1 to 2% of them are so rare that they are basically personal. In a patient, these are the candidate mutations that require further investigation, as one of them could be the actual disease course. If we had a larger cohort of patients with a similar phenotype, we would search for statistically significant associations, that is, more mutations in the same gene than randomly expected. This approach can be illustrated by a Manhattan plot. The number of candidate mutations on the y-axis is plotted over the entire genome on the x-axis, per gene, per case, or for the entire cohort. In this little toy example, 3 genes stand out: PIC-V, PIC-O, and MUC16. Maybe you remember that only 2 of them are from the molecular pathway that is related to hyperphosphatasia with mental retardation syndrome, while the third just harbored a comparable number of variants by coincidence. We wonder whether the power of identifying the disease-causing gene could be increased by using the Gestalt score. For our current study cohort of more than 200 patients, the PEDIA scoring approach is shown here. Each point represents a gene with a potentially pathogenic variant in a patient. The genes with the actually disease-causing mutations are shown in pink. The PEDIA score already integrates information from the molecular level as well as from the phenotype level. Let's imagine we consider only genes with scores above 0. Then we would exclude most of the neutral variants. Our results thus indicate that the accuracy of the disease gene inference can be significantly increased when Gestalt information is used for weighting. In the second step of the PEDIA study, we aim at identifying novel disease genes by phenotype matching. By this means, we intend to increase the test strength in an association study, and I would like to illustrate this concept in the following example. Hyperphosphatasia with mental retardation syndrome is a GPI anchor deficiency. Several genes are involved in the synthesis of its anchor molecule, and most pathogenic mutations have so far been reported in PIC-V, PGAP3, PIC-A, and PIC-N. We analyzed the images of these patients and compared their similarities in a high-dimensional phenotypic space. Interestingly, the 2 principal components show a clustering that is gene-specific. In other words, even in molecular pathway diseases, heterogeneity can be reduced by Gestalt matching, which can be used to increase the power in an association study. We will therefore define cohorts of unsolved patients that share a characteristic facial aspect. The Hallermann-Streiff syndrome that is defined by a proportional small stature and small eyes, a beak-shaped nose and a small chin, would be an example for a disorder without a known molecular course. Whenever there are enough mutually similar patients for an association study, we will contact you and ask for research collaboration. Everything is handled via the Face2Gene website. Just upload a frontal photo of your patient and enter the phenotypic features. If available, please also upload the VCF file with the exome variants. If it is a case that is already solved, please indicate so by confirming the molecular diagnosis and enter the pathogenic mutation in HDVS code notation. In this case, we will use the case to improve the PEDIA classifier. Now just add #PEDIA to the case name and you're done. If it's a patient without a diagnosis, we will offer exome sequencing if there is a critical number of matching cases. To be updated about the latest achievements of our study, follow us on Twitter and ResearchGate. If you have any questions, contact us via email pedia@charité.de. Our team consists of 2 clinicians, Dr. Med. Peter Kravitz and Dr. Med. Martin Menzer, 1 bioinformatician, Max Schubach, and 2 medical students, Noor Hajir and me, Jean-Tori Pantel. We want to thank our current collaborators and are looking forward to hearing from you. Thank you.